Okay, so now we're going to get into a bit more of the nitty-gritty about how and why we would actually use graphical intersections to solve equations, because I think for the moment it's probably been not super clear, and it's not really super clear to me even, to be honest, about why you would want to do that. So what we're going to look at is where we're solving unfamiliar functions. So functions where we don't necessarily know what they look like, but we want to find the solutions to the equation anyway. And we don't have things like quadratic formula or factorizing that we could use to solve it in a nice, easy way like we do with quadratics. Okay, so the first thing we're looking at, we've got one function here, which is f of x equals x cubed minus 2x plus 1. And we're wanting to solve for that, so that should say f of x equals to 1, by the way. That's my bad. We want to solve for where f of x is equal to 1. All right, so what we're going to do is the same process that we use when we're looking at solving a quadratic. So we're going to make them equal to each other, firstly. Okay, so we're going to make x cubed minus 2x plus 1 equal to 1. Now from here, we're going to split it so that we've got the x cubed on one side and the rest of the things on the other side. Because again, we want to keep it kind of as basic as possible to be able to solve. So we're going to keep the x cubed there. And then we're going to minus off, or add in this case, the 2x and cancel that out, and minus the 1 and cancel that out. So we're going to be left with 2x, and 1 minus 1 is 0. Okay, so you can put the plus 0 on the end if you want, but I don't really want to. So in this case, we've got an x cubed function, and we've got a 2x function. Now we're going to go through and we're going to plot the points for this. Okay, so x cubed. So we're plotting between -4 and 4. So the first one we're going to look at is -4 cubed. Now, if I get my calculator up, okay, I'm going to type in -4. Remember to put the brackets in for a negative. Okay, cubed equals, okay, -64. Now that's not going to be actually on the graph, but that's all right. Okay, -3 cubed, okay, so -3 times -3 times -3, and that's -27. Okay, -2 cubed, it's -2 times -2 times -2, so that's -8. -1 cubed is -1 times -1 times -1, which is -1. Okay, so I'm just going to plot some of these on here. So -3 and 27, -27, that's me down there. -2 and 8 up here. -1 and 1 there. Now we're going to go through 0, 0, okay, because 0 and 0. And then we're going to go with the positive values. So 1 cubed is 1. Okay, 2 cubed is positive 8. 3 cubed is positive 27. Okay, and we're not going to put 4 cubed on there because it doesn't fit. So now we're going to go through and we're going to join these up. And you'll notice that you kind of get this, like, it's kind of like a quadratic up until this point, and then it turns around and you get like another kind of quadratic on the other side. And that's a cubic graph. Now, you're not expected at the moment to be able to draw these or know them off by heart, but you should be able to plot them just by using the points if you need to. Okay, so there's my x cubed. Then I'm going to look at the 2x part. So again, over the same values, we're going to use 2x. So we're going to do 2. We'll even put the -4 for this because that gives us -8. So we've got -4, -8, that's there, okay. And we've got 2 lots of -3, so that's -6. 2 lots of -2, it's -4. 2 lots of -1 is -2. That's there. And 2 lots of 0 is 0. So we've got 1 point there. Right, now again, we're going to go back in the opposite direction. So now we're going to have 2 lots of 1, okay, which is 2. 2 lots of 2, which is +4. Okay, 2 lots of 3, which is +6. 2 lots of 4, which is +8. All right, I'm going to join up these. Now, you should notice how many times with the cubic do we cross, okay? And again, remembering that my graph drawing is a little bit dodgy. Okay, so there's my intersection points. Now, we should actually have, in this case, 3 points of intersection. This won't be true for all cubics. Okay, but we've got 1 point of intersection here. We've got another one at 0, 0, and then we have another one at 1 there. Okay, so my solutions for this, So x cubed minus 2x plus 1 is equal to 1 at x equals, so it's about negative 1.7 at x equals 0 and at x equals, I reckon, 1.2. Okay, so then my three values, 3x coordinates there. Now again, if you wanted to jump onto GeoGebra, just grab this up. If you wanted to go onto GeoGebra and just check some of this, okay, we could input that. So it was x cubed, so you're doing squared, x cubed minus 2x plus 1. And we were solving for where that's equal to 1. So g of x equals to 1. Okay, and then we could go through and we could chuck in, look at those points of intersection. So 1 here, okay, 1 here, and 1 here. Okay, so my points of intersection are at negative 1.4, 1.0, and about 1.4. So in this case, I think my graph is not as accurate. Yeah, I got negative 1.7 and 1.2. Okay, so they're not bad, but it's not amazing. X equals 0, perfect. That's definitely on there. Okay, all right, so that's your cubic with the solutions. Alrighty, next one. Okay, so this one, we've got 2 to the power of x minus 4, and we're going to graph between negative 2 and 4. And we're going to solve for that's equal to y equals 8. So again, first thing we're going to do, same thing every time, is write down the equation, make it equal to the value that you're looking at, and then we're going to solve it so that we've got the part with the x, we do the, one easy part on one side, one easy part on the other side. So we're going to add 4 to this one, so plus 4, and we've got 2 to the power of x on one side, and then 8 plus 4 gives me 12 on the other side. So this, in this case, we're graphing this function versus this straight line. Right, so I'm looking between x is negative 4, x is negative 2 and 4. So 2 to the power of negative 2. Okay, well, hopefully you guys remember a little bit of this from way earlier on in the year, from when we were doing, delete that. We were doing index laws. So 2 to the power of negative 2, that's the same as 1 over 2 squared. Okay, which is 1 over 4, so it's a quarter. Okay, so negative 2, we've got a quarter, so that's like almost 0. I'm just going to put that in there really small. Okay, 2 to the power of negative 1. Again, on your calculator, if you want to, you can just change that to a negative 1. Okay, gives you half. So at negative 1, we're going to have a half. That's just a little bit further up. 2 to the power of 0. Now, anything to the power of 0 is 1. So 0, we've got 1. 2 to the power of 1 is 2. So at 1, we've got 2. 2 to the power of 2 is 4. So 4 there. 2 to the power of 3 is 8 here. And 2 to the power of 4 is 16. All right, so there's, oh, that's not 16 at all. 16 is a lot further up. 16 up here. That is 8 though, so that's good. Okay, so now I'm going to join up the points again. Again, it's pretty flat. This is what we call an exponential graph, because it grows exponentially. So you can see it gets steeper and steeper and steeper really quickly. All right, now I'm going to plot in my 12. So I'm going to find 12. So negative 2, 12, that's there. Negative 1, 12, 0, 12, 1, 12, 2, 12, 3, 12, 4, 12. All right, I'm going to join up these points. Okay, so now I can see, in this case, only one point of intersection because the graph doesn't come back on itself. Okay, and that's at around about, I reckon, we call that about 3.6, I think. So I'm going to say, so that's about, yeah, I'm happy with that, 3.6. Okay, just going to bring my screen down. So I would say then, therefore 2 to the power of x minus 4 is equal to 8 when x equals 3.6. Okay, and again, can check that on GeoGebra if I want to. I'll just turn all these off. Okay, so we say h of x this time equals 2 to the power of x minus 4. Okay, so that's what my original graph would have looked like. Okay, then I'm going to chuck in I of x equals to 8. Ooh. Nope. Nope. What was it? I've forgotten what the actual... Yeah, equals to 8. Okay, so then I'll go a of x. A of x equals to 8. Oh, all right, I see what the problem is. I haven't scrolled down enough. Okay, so equals to 8, so there's my graph. And if I find that point of intersection again, intersect, put that in on that there. Okay, and I go back and I look at that, and I can see that that's equal to 3.58. So yeah, around about 3.6. So that one was actually pretty accurate. We did well with that one. Awesome. Okay, so hopefully this kind of shows you now why you'd use this graphing. It's to make functions easier so that when you don't have those factorizing techniques and the other ways of solving, then you do have methods of being able to do that. Okay, I'm going to stop this video now. I hope that makes a little bit of sense. There'll be some questions for you to do. For these ones, I think it'd be best, I'm just going to send you like a PDF to do, and you can print it out and have a go at those. And if you've got any issues, you can let me know. All right. Okay, thanks very much, guys. See you later. Bye.